Now let's look at a linear equation that has two variables. Let's look at the example where we find the solutions to the equation 4x plus 2y equals 8. Since this equation has two variables x and y, solutions are pairs of values for x and y that make the equation true. Since we need to find two values, we will start by picking one and finding out what the other should be. If x is 1, is there a value of y that gives a solution? Well, if x is 1, our equation becomes 4 times 1 plus 2y equals 8, which means that 4 plus 2y equals 8. To find the y value, we first subtract 4 from both sides, which gives us 4 plus 2y minus 4 equals 8 minus 4. On the left, since 4 minus 4 is 0, we just have 2y. And on the right, 8 minus 4 is 4. So we're left with the equation 2y equals 4. To get y itself, we divide by 2, giving 2y divided by 2 equals 4 divided by 2. On the left, it simplifies to just y, and on the right, 4 divided by 2 is 2. So we are left with the solution if x is 1, y is 2. We write this solution as 1, 2. Let's try other values of x to find other solutions. Since picking a value of x led to a solution, let's pick another value of x to try to find another solution. If x is 2, is there a value of y that gives a solution? Well, if x is 2, we have the equation 4 times 2 plus 2y equals 8, which means that 8 plus 2y equals 8. To find y, we subtract 8 from both sides, giving 8 plus 2y minus 8 equals 8 minus 8. On the left, 8 minus 8 is 0, so we just have 2y. And on the right, 8 minus 8 is 0 as well, so we have the equation 2y equals 0. Now dividing by 2, we get 2y divided by 2 equals 0 divided by 2. The left simplifies to y, and the right is still 0. So we are left with a solution x equals 2 and y equals 0, which we write as the point 2, 0. Let's try another value of x to find other solutions. If x is 3, is there a value of y that gives a solution? Well, when x is 3, our equation becomes 4 times 3 plus 2y equals 8, which simplifies to 12 plus 2y equals 8. Now subtracting 12 from both sides, we get 12 plus 2y minus 12 equals 8 minus 12. The left simplifies to 2y, and the right is negative 4. So we need to solve the equation y equals negative 4. To do this, we again divide by 2, giving 2y divided by 2 equals negative 4 divided by 2. The left simplifies to y, and the right is negative 2. We are left with the solution x equals 3, y equals negative 2, which we can write as the pair of numbers 3, negative 2. Let's try another value of y to find other solutions. What if x is 0? Is there a value of y that gives a solution? Well, if x is 0, our equation becomes 4 times 0 plus 2y equals 8. 4 times 0 is just 0, so we have 2y equals 8. We can divide this by 2 to get 2y divided by 2 equals 8 divided by 2. The left simplifies to just y, while the right is 4. So we are left with a solution x equals 0, y equals 4, which we can write as an ordered pair 0, 4. How many of these x values should we try? Every x gives a solution, and there are infinitely many x values, so we have infinitely many solutions. Since there are infinitely many solutions, a list will not be a good way to display our solutions. Instead, let's use a graph. We place the red point, 1, 2, on the graph where x is 1 and y is 2. The point 2, 0 is when x is 2 and y is 0. 3, negative 2 is when x is 3 and y is negative 2, and 0, 4 is the point where x is 0 and we just move up along the y-axis 4. So far, we have found 4 out of infinitely many solutions. Let's find some more solutions to get a better understanding. Before we proceed, let's look at how we have found solutions. To find solutions, we've done the following steps. We've picked the value of x. Then, to solve for y, we started by subtracting whatever 4 times x was, and then dividing by 2. If we first solve for y, then we only have to solve for y once, instead of doing it every time we pick a new value of x. It's worth noting that this change is not necessary, but it makes solving easier. So to solve for y, we'll first subtract 4x. This gives the equation 4x plus 2y minus 4x equals 8 minus 4x. On the left, 4x minus 4x is 0, so we just have 2y, like we did every time we picked a value of x. Then we divide by 2 on both sides. This gives 2y divided by 2 equals 8 minus 4x divided by 2. On the left, this reduces to just y, and on the right, 8 divided by 2 is 4, and 4 divided by 2 is 2, so we have 4 minus 2x. Now, using y equals 4 minus 2x, we can find solutions much faster. We say that y equals 4 minus 2x is an equivalent equation to 4x plus 2y equals 8 because they have the same solutions. Let's use this easier equation to find more solutions and add them to our list. So far the solutions we found are 1, 2, 2, 0, 3, negative 2, and 0, 4, which we have graphed below. If x equals 4, then y equals 4 minus 2 times 4, which is 4 minus 8, which is negative 4. So we get the solution 4, negative 4, which we can add to our graph. Next, let's try x equals a half. Then y equals 4 minus 2 times a half. Since 2 times a half is 1, this is 4 minus 1, which is 3. So we get the solution 1 half 3, which again we can add to our graph. If x equals negative 1, then y equals 4 minus 2 times negative 1, which is 4 plus 2, which is 6. So we get the solution negative 1, 6, which again we can add to our graph. If we continue this process of finding and graphing more solutions, we get a great picture of what the graph of solutions looks like. As we find many more solutions, we see that they form a line. It's worth pointing out that this is why we call these equations linear, because they form a line. More generally, we get a line of solutions to equations of the form ax plus by equals c. In this case, our a is 4, our b is 2, and our c is 8 in the original equation. Let's make some observations. Since a line is determined by 2 points, we can find the entire line of solutions by finding just 2 solutions. We also notice there are 2 interesting points where the line hits the axes. These 2 points are called the x and y intercepts. The x-intercept is where the line hits the x-axis, and the y-intercept is where the line hits the y-axis. So we can get all the solutions just by finding the intercepts. We'll see how to do this in the next video.